In this lesson, I'm going to talk about one of the most mysterious parts of TensorFlow-Lite Micro's interface, the op resolvers. Op resolvers exist to help reduce the amount of space that the library code takes up. The functions that make up the library, compile down into machine code instructions and take up all the space, typically in Flash. Flash is a limited resource on embedded devices, and there's often just, tens of kilobytes available for your application. This means that if a library, compiles, the compiled code is too large, it won't be usable by applications. To help minimize the binary footprint of the library's executable code, TensorFlow-Lite Micro is broken into two main sections. The core functionality includes things like, model loading and the interpreter, and is always required. But we aim to keep this size, below 20 kilobytes. The second section contains the code that implements the operator calculations, also known as kernels. These are divided up by layer and are designed so that they can be independently included or excluded from the compiled library. The reason for this design is that there are potentially a lot of different operators that we might need to support, over 1,000 available in the TensorFlow training environment. Most models are only, use a handful of these operators. And this means that it's important for, binary size to be able to only include the operators that you need for your model. And so this is what, op resolvers are for. They're a way of specifying what operators you need at compile time so that the other code can be removed. Most models only use a handful of different operators. So the majority of space is taken up by, op implementations is wasted if you include all operators. In order to avoid linking, in this unused code, we use the op resolver mechanism. This class is a way to let the application developer specify explicitly which ops you want to be included in the library and then to actually compile them in. For example, the micro speech model uses just 4 different kinds of layers. And this means that you can use, micro mutable op resolver class to pick just the 4 operator implementations and not any of the other ops implementations. And then we create an instance passing in how many operator types we'll want as a template argument, and then we add each layer that we'll need. Each layer in the graph corresponds to an operator type, that we add to the resolver. And then as we go through and understand our code, we just keep adding each operator over there. The simplest way to understand what ops are required is by using a visualizer program like Netron to view the graph and include the op types, that are visible. If you're not, memory limited, you can use a special all ops resolver, which pulls in all supported operator types at the cost of a larger library size footprint. Using op resolvers can dramatically reduce the binary size of your executable. So I hope that this has helped you understand them a bit better.